All right, welcome back, everybody. Today, remember, we're going to kind of split it up a little bit here, and it's super chill day because we're going to check this, and then the only other thing that we're going to do is have time to talk about no-cart stuff. Okay, so going through, there are 33 points on the raw score version of this. When I put it in the gradebook, it's going to be out of 25. I'm not just going to take away points. It'll just, whatever percentage you had will be out of 25 instead of 33. Okay, so going through this, on the first problem, all three parts, I was checking for two things. Did you use this formula? And my hope is that I can see it written. My guess is you probably didn't have n minus 2 times 180, but I'm hoping that when I look at your work, I'll see 10 minus 2 times 180, and I'll see 11 minus 2 times 180, and I'll see 13 times 180. Okay, here's what they should be: 1440, 1620, and 2340. Cool. Sweet. I'm just going to skip it. I don't really have a whole lot to add. These problems, the most common mistake, most people who did this problem got x equals 7, no problem. But if we look very closely, there's also a y in this problem. So, you need me to zoom in, Ashley? Chelsea? Gosh, it's been so long since I've done that. Sorry. Yeah, it's been a long time. Yeah. All right. So, for this, check it out. This is a parallelogram, which means I know the opposite sides are what? They are congruent. Just set them equal. 2x plus 9 is equal to 4x minus 5. We get x equals 7. Now, for the y part, here's where y lives. My first question, how do I know that's 83 right there? They're alternate interiors. I have parallel lines here and here cut by this transversal. I know that's 83. Now, I just did a little bit of quick math. I knew that those two added up to 65. If you give me a parallelogram, any two consecutive angles better add up to what? So you'll see here, if I did, this is 65 plus 83 plus 4y, that's all those big angles, it better add up to 180. Here it is. 65 plus 83 plus 4y is 180. We solve, we get y equals 8. Okay, when you see on my key that it says try, just so you guys are all aware, I'm looking for, is there a valid attempt at this, like along the right path? If you tried and you graphed a quadratic, probably won't give you points. I might be impressed that you were able to get a quadratic out of it, but I'm looking for a try in the appropriate direction. Okay, 3 points there, 3 points here. Opposite sides are still congruent. Boom, set them equal, we get y is 6. What does this symbol mean? Okay, so as I was looking through it, and not this problem in particular, people get goofed up whether I'm looking for an angle or a side and what's given. The degree symbol is how you make that determination every time. So what's true about opposite angles of a parallelogram? They're congruent. So 115 had better be equal to what? And when you solve that, you get 37. Cool. The proof we will do together here in just a moment. It's worth 2 points. If you tried it and you did a couple lines of work that are reasonable and you like a real honest effort, you got a point. If you got it completely right, you got your other point. Okay. On this one is one place where I saw people getting all goofed up. I want this to be a parallelogram. Now, I added these little arrows so there was no confusion. These are talking about like x plus 4. Is this a length or an angle? How can you tell it's not an angle? There's no degree. What do the diagonals of a parallelogram do to one another? So x plus 4 better be the exact same as 3x minus 6. You do that, you get x is 5. Okay, what's the relationship between 5y and any other angle on this thing? Alternate interiors. We need it to be parallel, and if it is parallel, then these angles are alternate interior and they're congruent. When you solve 5y equals 60, you get y is 12. Cool. 3 points there. Did you try? Did you get a value of x? And did you get a value of y? Cool. This one is the place where everybody, not everybody, but I saw a lot of issues third hour. I haven't graded all yours. I haven't looked at them. Just so you're all aware, on the actual test tomorrow, there will be a slight difference. There will be a problem like this. I guarantee it. It might not be exactly the same, but something along these lines. But I'm going to add something. I'll tell you whatever, and then I'll say provide a short justification for each. Now, when I say provide a short justification, like that stresses people out a lot of the time. I don't mean it to do that. I mean to give you like a million different ways to answer it. The only way that I don't want is theorem number. Like, I don't know what number this is. But do we all agree this is a rectangle? Because it was one right angle and now I know they're all right angles. I think that you telling me it's a rectangle is enough to justify. If you wanted to be wordier with it, that's valid. I know that rectangles have to have each angle as a right angle. You could say that bigger statement if you want to use it, but just rectangle will suffice. If I know that's 57 and that together these two angles add up to 90, the only other option is 33. It has to be, and I'm using the fact it's a rectangle. Okay, for this one, I'm a monster. When we start getting into more application stuff, which it's coming because we get to move on to a fancy new idea here in a couple chapters called trigonometry. It's not really scary. It sounds scary. But we're going to be moving toward like word problems and nothing but, essentially, which means units, if they're specified, include them. Very seldomly do I specify the units, and your book does a terrible job with this. If you didn't give me feet and tell me that you're talking about a length in feet, I probably won't count it. Like if Ronaldo and if I say, Ronaldo, how far are we apart? Just give me a number. Okay, so we're going to go a real number. I think Relly and I, the distance between she and I right now, probably about 10. Now, obviously, maybe not obviously, do you guys know what I'm talking 10 whats? It's probably feet because you know how it works. But if I don't specify, it doesn't mean it, right? Like right now, I'd still say the distance between Relly and I is 10. Inches, centimeters, something, right? It matters. And if you don't have it right in front of you, you would have to see it. Cool. Thanks. Let me get close there. All right. The diagonals are the same as how we got 64. Cool. If this is 32, then that's 32. And the diagonals of a rectangle are, let me rephrase that. The diagonals of a rectangle are congruent, equal, murmur, whatever you want. Okay. Let's see. HEF is this big angle up here. It's angle E. And I want to know if I add EFG to that, which is this big angle up here. Are those next to each other on my parallelogram? For sure. And is this rectangle a parallelogram? So since they're next to each other, what two consecutive angles add up to? 180. Boom. Without anything. They're consecutive. They have to do this. Okay. Questions anywhere in here, whether you have your test in front of you or not? Any of them super hard yet? I don't see any tears running down faces to show that like it went really poorly. All right. Let's look at this one. Is 6 hard enough that we need to work through this problem together? Okay. ABCD is a rhombus. Why do I specify so hardcore that it's a rhombus? I even underlined it when I did it. So that's a parallelogram. I don't care if it's a rhombus, but they do that. But they bisect in a particular way, perpendicularly, which allows me to add this right angle. Now, with said right angle, if we look at just one little region of it, like, I don't know, this region, how many of the sides do I have marked? Well, you say, well, maybe. I see that's 9 because that was given, and that's 12, right? Those are 2 of the 3 sides of a what sort of triangle? Of a right triangle. Whose theorem will work? Pythagoras theorem or Pythagorean theorem. Here it is. AE or XA, whatever you want to call it, squared plus 9 squared is 12 squared. We get 63. If you stopped at whatever squared equals 63, I don't count it because I needed AE. How do I go from AE squared to AE in one step? Okay, I would have taken like 3 different answers. I would take root 63. I'm good with it. No units listed, no units included. I would take 3 root 7. I don't think anybody did it, but maybe you did. I would also take 7.9 something. I don't know what the number is, but it's in there. Okay, Pythagorean theorem is going to show up on figures that have right angles. Okay, measure of, what does this say? Like measure of angle. Now, that means I need an answer with feet or units or degrees. Degrees. It's an angle. So let's find B to D to A. B to D to A is right here. Now we'll go back to the other theorems. What do I know the diagonals of a rhombus do to those angles? Bisect. Now, if I knew that this one up here, ABD, is 55, what's this one? So 110 total. What do I know that this angle is on the opposite side of this really fancy parallelogram? 110. And it gets cut in half, right? That's what the diagonals do. What's half of it? We done. Okay. Here's where it gets a little wonky. If you, and somebody in here I'm sure did, I don't care who it is specifically, I'll see it. If somebody got A wrong, there's almost no chance of getting C correct. I try to avoid questions like that. If you got AE wrong, but you said, I don't know, 12. If you put 12 here because they're the same, I'm going to give you the credit. What should it be knowing that AE and CE are the same though? It should be root 63. Whatever you wrote on A, if it matches C, you get your point. Cool. All right. And the last one, ACB. A to C to B. Now, if that's 110, sorry, if that big angle is 110, what angle must this be down here? C. I heard 110 and I heard 70. One of them is correct. 70, because consecutive angles must be 180. So that's 70. And what do the diagonals of a rhombus do? So if you cut 70 degrees into two equal parts, each part would be how many degrees? We done. It's 35. Cool. All right. It all comes down to the theorems. And I have, I hope, a nice suggestion for how to write the theorems. Okay. I'm going to call out somebody that's not in this class. So not always. I try pretty hard to do the key before you guys. And I want to highlight out, I make mistakes. Now, typically I don't make mistakes in geometry calculations, but it happens because I'm a human, I'm pretty sure. The other day in third hour, I did this problem. And as I was walking around while people were testing, Raylene, I looked at her work and I started looking at it and I couldn't find anything wonky with it. And I came back to mine and I was wrong. Raylene was right. So if you see her, congratulate her, like she fixed my key essentially. But I'm looking for 2 questions or 2 points on this one. If it's a kite, that's a right angle. And if that's a right angle, then I now know 2 of the 3 sides of this lovely right triangle, and Pythagorean theorem is back at it. You should come up with the square root of 369 or 3 root 41 or about 19.2. Any of these are okay. If you gave me and you stopped, and I don't know if you guys did or not, but third hour people did. A lot of people stopped here and thought they were done. If they stopped here, have they really told me what side C was? Sorry, if they stopped here. No, they told me what C squared was. They need to go one more step. If you stopped here on yours, I will take off half point for it, just so you're aware. Okay. Oh, question? Yep, I didn't really think that, but I got goofed up as I was writing it. But yeah, it happens. Okay, for this one, parallel lines, transversal. What do consecutive angles always add up to if you have parallel lines? So 112 plus this must be 180, right? It's 68. Okay, should we do number 8 together? Yeah. I might have done it with small groups. Definitely didn't do it with everybody. We're going to talk it out. Now, you guys, some of you guys requested graph paper, and that's fine and dandy. Is because the picture makes it look like it an okay justification? It's definitely not valid. It will not get you points. Okay, that's fair. Did you not hand yours in?
Oh, no, you took only.
Okay, I already graded yours. Okay, all right, good. So let's clear this. Okay, I'm going to give you a parallelogram, and I'm hooking you up, and I'm going to do a really lazy job of sketching it. Now, if you use graph paper, I'm fine with that, but you don't have to be perfect with it. But I'm going to draw big enough that you can see it. I know that I get some points. I get point S at 0, 0. And I get point T that's somewhere up here, and I know it's at 6, 6. And I get point Q over here at 12, 0. Klein, you okay over there? Okay. No, you're good. If you guys are talking math, I would like to be able to chime in. Okay. Here's a random thing. Do you guys know where your funny bone is? Nope. That's just it's just a reflex is all they're checking. If you're brain dead, like if you have a traumatic brain injury and you do that to somebody, their leg won't kick. Yep, that's how you check, like, is the brain connected to the body? Anyway, here's a random fun fact interjected into the middle of this. If you hit your funny bone, your whole like nerve tingles, and it's not funny, like it's uncomfortable. Do you know why it's called the funny bone? What's this bone? That's a muscle. That's also a muscle. It's your humerus. And if something is humerus, another word for it is, it's literally because it's your humerus bone. Yep. All right. So check it out. I didn't put any real effort into making this scale. You guys just saw me. I just plotted the points roughly. Is that a square? It looks kind of like a square, right? Okay. Now, if we want to verify this, what does it mean to be a square, I guess? It's really two shapes. Okay, so if all sides are the same, because that's one of the easy ones, you've just told me the definition of a what? It's a rhombus, and there's ways to check these, and we'll do two different sections. It's a rhombus, and I heard Honor say 90-degree angles, which she's talking about a rectangle. If I can show convincingly, mathematically, other than because it looks like it, that these things are true, then we're fine. So let's just work to this, because there's some variety of ways you can do this. The first way is not the way that I would recommend it. If it's a rhombus, tell me some things we know that are true about rhombi. All four sides are congruent, so it's not the way I'd recommend doing it, but check it. I'll just show you guys here real quick. You could check all four lengths. Now, I can do it a little quicker than most of you guys because I think I'm better at mental math most of the time. All four lengths are the same. But if you don't want to do four distance formulas, it would sure be nice if there was another way. What else is true about rhombi? So the opposite angles are congruent. Now, unfortunately, we don't have a good way to check angles yet. We haven't done the trig stuff, so we'll have to get there. What else is true about rhombus? The diagonals bisect, but that's parallelogram. Perpendicularly is the way that you can focus on this. If I sketch this diagonal and this diagonal, there's a couple things that we can do that's going to shake out in here. First off, what's the length of this part? 6. And this one? And this one? And this one? Whoa, I almost wrote the wrong number. Okay. Klein, just to make sure you're focusing, do you agree with that statement? And what is the statement, just real quick? So if you're talking math to add to it, because we are testing tomorrow, I just want to encourage, if you're ignoring what I'm doing right now, I have no sympathy if you bomb this question on the test tomorrow. Okay, check it out. It's my phone, sorry. I can now see that the diagonals were bisected. Okay, so that's an easy part. What's the total length of this one? And the total length of this one? Well, what shape has diagonals that are the same length? So as soon as we see both diagonals are 12, I think, so not square yet, Sonny. Both diagonals equal to 12, it guarantees to me rectangle. Check. We have a rectangle. Now, if it's a rhombus, then the angles here would have to be what? So the angles. 90. Now, we don't have a good way to check angles except for this one, and we're going to rely on a little bit of algebra. Could we find the slope of SQ? So remind me real quick, slope, and you may not need to write all this, but it's a good review. What letter do we use? M. And how do you think of slope? So I hear a lot of y equals stuff beyond what I need. It's the rise over run, which is more commonly written as a change, or delta y. That's a change in the y direction, how much we've risen, over delta x. Now, for this, some weird things are going to happen in this problem, but it's a good algebra review. What's the slope of SQ? Which I'm going to write down M, and I'm going to use SQ as a subscript. How much do I rise from 0, 0 to 12, 0? So 0 rise over how much run? 12. What's 0 divided by 12? 0. Now I'm going to make a big point, and there's a reason I'm making this big point. That is a horizontal line. Wow. Anybody disagree with the fact that this line has a slope of 0, which just means it's horizontal? Like, you're good with that. What's the slope of TR is my next question. Sonny says undefined. MTR. Well, how much do we rise from here to here? Sorry, here to here. So 6 to here, and then 6 more, right? It's rise 12 and run. Are you allowed to do this? And real quickly, just to make sure we're all on the same page, what's the this thing that we're not allowed to do ever? You can't divide by 0. This does not equal anything. I know I'm writing equals. This is undefined. There's only one type of line that you'll ever draw whose slope is undefined. It's not a horizontal. It's a vertical. Now, with these, it doesn't really make sense to say opposite here, but if I put a horizontal line and a vertical line, what angle do they form? It's a right angle. Now, alternatively, you could say it's the opposite reciprocal, but it doesn't really make sense to talk about the opposite reciprocal when you have one of the numbers that just doesn't work. Like these are straight up just flipped, and I can see the reciprocal part, but because it's 0, this could be like negative 0 over 12, and this is 12 over 0. Like it still works. These things form a right angle, which means we now have a shape that's a rectangle and a rhombus. Therefore, it's a square. Now, it is not the only way to do it. And checking this. What's up? I erased the symbols. It was just getting too cluttered. I'm going to write the ones that we use regularly again. Cool. And actually, I might put them up there so we all have access to them. Okay. Now, there are other ways. Could we have found the slope? And I'm just looking. If you don't like the diagonals, that's fine. Can we calculate the slope of this line real quick? SR. Over 6 and down 6. What's the slope? So down 6 is negative 6. And over 6 is 6. Do you agree that that simplifies to negative 1 over 1? And I know the over 1 part you might not put, but let's check the slope of RQ. How much do we go up? And how much do we go over? 6. Do you agree that's 1 over 1? Did we just have opposite reciprocals? So this is another way to show that what was the angle right here? If the slope of this is opposite reciprocal to this. 90. And if I have a parallelogram with one right angle, it must have 4 of them, and I could have concluded a rectangle that way. Okay, there's lots of ways to do this problem. The way that I'm going to assign points, I honestly did not even care if you drew it or not. Most people elected to, and that's fine. I need to see some of this. I need somewhere to see something done that you've checked and confirmed it's a rhombus. If you've done that, it's a point. I need some way to see that you've checked and confirmed it's a rectangle. If you did this, it's your second point. If, and this is me being super kind, if you didn't do either of those, and you're already thinking, oh, crap. As long as you said it's a square at the end, even if you didn't show me the justifications, I'm going to be super kind and give you a point. Okay, I need you to show me somehow, and there's various ways you can do it. I use slopes normally. I did not read that it was a parallelogram at first, so here's my check for that, as always. I need to see all 3 of them. Cool. All right, for the last one, I would say if you have that statement written, I know that you're talking about rectangle. I would like to see you say, therefore it's a rectangle, and do it all, but I'll say the logic. Yeah, we have one more problem to go through. You're good. Other thing, I'm going to be more hardcore about it. First 10 minutes and last 10 minutes of class. Did other teachers talk to you about this already? Okay, I'm not going to let you go to the bathroom to get water. First 10 and last 10, you're in here. Cool. But yes, you can go. I already graded your test, yeah. I already graded your test. You're good. Cool. All right, last one. Okay, a couple things. What is just that equation? N minus 2 times 180.
Finding the sides of
So careful. Is the sum of the angles. If you give me an n-gon, this is what all n angles add up to. So we're going to do a little weird thing right here. Imagine a 3-gon. How many angles are inside of any 3-gon? 3. What about a 4-gon? A 5-gon? An n-gon. N of them. So this just tells me what do all the angles add up to. If I had, let's say, hypothetically, 10 sides, and I knew that there were 10 angles that were the exact same, I would just take this number and I would divide it by what? Or by n again, right? It's the same thing. Now, what do I tell you the calculation should give me when I say for this polygon, all the angles divided by the number of sides, it gives me what? Is this a solvable algebra problem? Help me out. What's the first thing you would do?
multiply by
Multiply by n. You got it. Now, I did 2 things. I multiplied by n to get out of the denominator, and I distributed. One more step. So add 360, subtract 170. you get 10n equals 360. How many sides did this polygon have? Sevilla says 36. I like it. If you stopped at n equals 36, I'll give you the point, but it's 36. Now, these things, they're wonky. The second one should be 180. And if we think about why this happens, it seems logical. Because if we think about 180 sides, as I start adding more and more sides to some polygon, like this just looks like a rectangle, right? Or a square. If I make it 5 instead, it doesn't look like a square anymore, I don't think. And that's pretty close to a regular polygon. That one's actually really good. Boom, I'm pretty proud of that one. Does it look like a circle to you? Not really. Does it, if I add more sides, does this look more like a circle? If I start adding more sides. Now, if I add more and more sides, is it going to look more and more like a circle? And let's just see what happened. This angle was a what? 90 degrees. Now, you won't have this off the top of your head, but this one's 108. And this one, I think, is 120. I think I could be wrong. But if I got to 178 degrees, that means eventually I'm getting down, if I zoom way in, to like that angle. Right? That's pretty close to 178. My next angle then is like over here. If I were to do this for all the sides and say, there it is, and there's another one, and then there's the other one, and then there's the other one, and there's the other one, what does it start to look like? And of course, it makes sense it would take a crazy number of sides if you had that big of an angle, because you have to go just a little tiny bit each time. That's 180-sided polygon does make sense. It's looking more and more and more like a circle. All right, we're going to do the proof together real quick. Okay, now the proof, always worth 2 points. Can you tell me where the points come from?
Trying.
Like really trying it, right? And do you get there? So first and foremost, very, very specifically, the proof on your individual test is nowhere near as challenging. Like, not a chance. I'm going to give you guys harder stuff, and I try to give you like noticeably harder stuff for practice tests or team tests so that when you do the other stuff on your own, it's not as terrible. So here's my figure. Do we want to formally write the proof? Okay, let's formally write this then. So I'm going to label all these points, A, B, C, D, and then F, E. A, B, C, D, and F and E. Those are backward. That's E and F. Okay. Now, we know a few things about this. I know that AE is the same as CF. Okay. Sevilla, I'm dying of thirst. Will you go get me a drink? Cool. Sweet. All right. Anybody recall what we're given? Parallelogram and I'll just write it. AE is congruent to CF. Okay. Given. Now, there's a long way to do this proof, and there's a much shorter way to do this proof. We'll see which one we get. Now, right off the bat, since it's a parallelogram, anything that we get for free? A is the same as C. I'll take it. Angle A is congruent to angle C. Why? And I'm like, honestly, if you just said parallelogram, I'd give you credit. This is how I think about it. Opposite angles. But it's of a parallelogram. Okay, deal. So I know that's true. What else? So AB and CD are the same? Okay. AB is congruent to CD. Opposite sides. Can I say what? Yeah, I'm fine with that. BC is also congruent to AD. Okay, have I done anything wild yet? Have I lost anybody? Like, we're just writing down the obvious truths, I hope. Okay, here's the hard part, and I'm going to check with you guys. You sure? All right, are you sure? Are you sure you're sure? Okay, so check it out. We have a few different approaches. Now, I want you guys to check your notes for me real quick. I have no idea what theorem number it is, not a clue. But I know that when we did one section, we said tests for parallel or tests for parallelogram. Find me what test 4 says in your notes. Like, grab your notes because you're going to need them anyway. Test.
If the diagonals of the foregone bisect one another, then parallelogram.
Read me test 3 then.
If
One pair of opposite sides will suffice. If one pair of opposite sides is congruent and parallel, we have that somewhere. And I thought it was test 4. We are looking for test for parallelogram. There's 4 theorems in there. I think the 4th one says if one pair of opposite sides is congruent and parallel. Okay, read me test 3 then. Do we have a 5? Okay, scratch that. I thought we only had 4 tests. I believe it's test 5.
if one pair of opposite sides are parallel, then and congruent, then parallel.
Okay, this is what's going on in my head. One pair of opposite sides are congruent and parallel. If we say that opposite sides of a shape are both the same length and parallel to one another, we have a parallelogram. So now my mind has switched. If BC is the same as AD, if I can get to this point where I can say that and that are the same, and I'm talking BF, and that and that are the same, then we're golden. Like, that's my end goal in mind. Now, you can do other stuff. You can show both pairs of opposite sides congruent, and we're not terribly far from that either, because these triangles are congruent, so we can use that. I want to get to these red marks, and I want to see if we can make that happen. I'm going to keep the red marks up there for now, and I'll replace them with blue when we get there. Here's my kind of entry in. What is BC equal to? Give me something else other than AD. I would probably write D. This is the fast route through. I'm going to make a claim. BC is equal to BF plus something. FC. And all I'm doing here is I'm saying, hey, this big piece is just this small piece plus this small piece. And I don't think that that's a stretch. Okay, now I'm going to notice, I'm going to change the marks when I add it. Right now it's just 1 and it's bugging me, but I'll switch it when we get to it. Okay, notice that has a BF in it. That's my goal. Well, what about the bottom side of it? AD is equal to what? AE plus ED. What is my justification for being able to write this statement? This is segment addition. So we're just adding up segments. Does everybody agree that this is true? Okay, let's go through here. Now, I'm going to be a little bit informal, and I'm just going to sneak it in here. If AE is the same as CF, like if they're congruent, they're equal, right? So check this out. Do you guys agree, and this is what somebody tried to give me from the beginning, that BC is congruent to AD? We already know that. So let's just do this substitution where instead of BC, I'm going to write this. I think that I can say BF plus FC is exactly equal to, I don't know, AE plus ED. If you are comfortable with this line, all I'm doing is I'm doing it with the smaller parts. Have I lost anybody? Okay, now let's look very, very carefully on our marks that I made and disregard the red ones. Is there anything that I could write instead of AE? Anything that's the same? Go ahead. Prime says FC. Does everybody agree that AE and FC are the same thing? Like they're marked as congruent. We wrote that they're congruent. The only thing I didn't write was they're equal, but we're allowed to say 2 steps in 1 here. So I'm going to rewrite this line. And instead of using BF plus FC, what did we just say that I could replace that with? AE equals AE plus ED. And all I've done here with F is what for substitution? Gosh dang it. What's my justification?
Substitution.
FM works if you don't know it's substitution, but you only get 1. So I'm just substituting it. What was ease? I think that was a substitution as well, because I just plugged it in for here.
So wouldn't that just
It could have been just E, but I just didn't write it. Okay, what could I take away from both? Can I subtract that from both sides? We then conclude that BF is equal, which is the same as meaning congruent to what? ED. So check it out. The marks that I commented, I'm going to mark them now. That is now the same as this. Okay. What allowed me to go from F to G? It's a property of algebra. What do we do to each side? We literally just use subtraction, right? Like, I think if you asked Miss Sweet for help the other day, she probably encouraged you to say the subtractive property of equality. I'm okay if we just say we subtracted. Okay, we're one step away. This last one, the wording's going to be clunky, but do we know that BC is parallel to AD?
Yes.
Is BF on FC? Like BF is literally a part of that larger thing, right? Now, I think I know the claim here, ABC of GH, that I'm going to make two claims. And I would do this in one step normally, but BF is on AC. And I'm also going to claim that ED is on AD. Do we agree with those? What do we know about BF or BC? Sorry. Oh my goodness, that's supposed to be a B. What do we know about BC and AD? Opposite sides of a parallelogram. So I'm going to sink this in as a given statement, like it's just there on it. They're congruent. Anything else we know about them? Opposite sides of a parallelogram. They're certainly congruent, but there's one more important part. They're parallel. If AC is parallel to AD, and these are just on those lines, can we conclude that BF must be parallel to ED? Like, does that seem reasonable? Which means I can now put these marks. As soon as I have those marks, where opposite sides are congruent and parallel, what do we conclude? We now know it's a parallelogram just from those. You don't have to do it this way. If you took a route and you said this is the same as this because of corresponding parts of congruent triangles are congruent, then congratulations, you have a parallelogram just a different way. Awesome. The proof on the test tomorrow will be nowhere near this bad. Okay. What's up? I don't know. I haven't written the test yet, to be honest. I don't know. We'll see. All right. It'll be easier than this. Now, just as a quick summary, because I definitely will not have time to get these back, I'm going to go through this one more time. If you guys would, I'm going to do this so there'll be like some background noise and stuff, which is fine. I'm going to hook you up. Anybody have a note card yet? Okay, there's a lot of stuff on these. I would rather you write more than that because I won't answer a single question if that's all you write.
Oh, I already have one filled out.
If you're good, if you want to use a bigger one, you can. But what I'm going to talk about, okay. Essentially, just so you guys know, the next 10 minutes is almost entirely yours. I'm going to start grading your tests. I will try to get them finished by 6th hour. If you want to swing by after school, I assure you I can get yours done by 3:30. But I did not have as much time. Now, the question that got 3rd hour, and I think it's a valid question, is somebody looks and goes, Holloway, how on earth am I supposed to put 26 theorems on this sheet? And I said, you probably can't. Not if you want to write them all. Do you guys agree with that? But check it out. I'm going to help on just one little section. I'm going to jump right in at parallelogram. So the theorems are the big ugly part. I would include the n-2. I'm only showing you how I would format it because we all need different stuff. I don't think anybody in here needs all 26 theorems. But if you're feeling like you got a lot of free time, you can do it. Here's what I would suggest. Theorems, and let's just start in with parallelograms. Because this is like the broadest shape that we have. So instead of writing all the theorems and all the numbers, I wouldn't. I would just say the following. A foregone is a parallelogram. And remember, this means parallel. If and only if, and this is how I would write these theorems. We don't need to write 4 or 5 or 6 different theorems or 8 here. Tell me some things that you know are true, whether it's a theorem or not, about a parallelogram. So opposite sides they are congruent, but there's one other part that's not really a theorem. And one more thing about them. It's going to feel silly because it's obvious once we do it. Parallel. Right? Like that's true. Now I would use this symbol. I'm trying not to use this symbol in case somebody in here doesn't, or multiple people maybe, don't have a lot of comfort with the symbols. Like I'm okay with it. You can ask about any of them and I'll tell you symbol stuff. As long as you have a note card. I was trying to make eye contact with Liam, but he stood up. What else is true? Bless you. Now this is two theorems, just so you know. Like we get the, if it's a parallelogram, then opposite sides are congruent, and if the opposite sides are congruent, then it's a parallelogram. So here's two of them already. Give me another one about parallelograms. Ooh, I don't agree with that. I think you're thinking rhombus. Oh, unless you're saying opposite angles. Okay. Opposite angles are congruent. All right. Any other parallelogram theorems? What do the diagonals do to each other? The diagonals bisect, and I'll write diagonals, bisect each other. Now, on any one of these, if you needed a picture with it because you're not quite sure what it means, or if you want me to use different language, I'm okay with it. What I would do is if you need the pictures or if you struggle with it, and this is totally optional, so only if you struggle with it, if we have some parallelogram hanging out here and we name it PARL, and we'll say E is in here, and this is totally optional, right? If you can make sense of this without drawing the picture, I would do it. If I wanted to use this picture, opposite sides congruent and parallel, I don't know that I would reference this picture. This one could be kind of tricky. What does that really mean as equal here? And this is just like a little example of that theorem from this picture. PE is congruent to what? ER. And LE is congruent to EA. Now, if you don't need the picture and a theorem to reference, I'm fine with it. Don't have it. But for any of these figures, if you are concerned with writing it down won't make you know what it's doing, add the illustration and then just say, oh, this is what the theorem gives me. Cool. Klein, you getting it clean for me? How much trash is in it if you look? Is there a bunch of garbage in it? But there's some. I think it does. It used to. I don't know. Okay. I guess not. I can't take it off. I don't have a bolt. All right. Any other theorems about these? There's one more. Consecutive angles. And I'm just going to say neighboring if you need that other word. Add up to, and there's a shorter way you could word this, but if you give me any two neighboring angles, P, A, R, and L, what do they add up to? 180 what? Degrees. Okay. We have 8 theorems on the board right now, or on my cheat sheet right now, because we have the statement and the converse. This is how I would do all the theorems for this chapter that you want to write down. I don't think you need to do 20 if it's a parallelogram then, and then if this is true then. Like, don't do them all. Just know how to use them. And honestly, 2 words are probably enough for me to know if you're using it to justify something. Okay, do you want my help here doing another small section, or is the rest of it pretty straightforward? Okay, would you like my suggestion on where I think you're not going to write stuff clearly enough? Okay, so let's talk about this. Interior angles. And this is going to be its own interior angle of n-gon. Okay, there's a few different theorems that people misinterpret here. And we saw them on the test, and I just want to make sure it's really clear. If you want to add up or find the sum of n interior angles of an n-gon, how would you do that? To add up all n angles of the n-gon. N minus 2 times 180. Now, if you need it, and I think it's included in here, but if you're not super comfortable with it, where n is the number of what? Good. The number of sides. Okay. So people get goofed up on that one. N minus 2 times 180. N is just the number of sides. So if it's a 7-gon, it'd be 7 minus 2 times 180. What does it mean if a shape is regular? All sides and all angles. So I'd say for a regular n-gon, yes. Thank you for asking. And I'm trying to make it small just so it's kind of the same scale, but I will try. You are A-okay. For a regular, is that bigger at all? Okay. N-gon. All n angles are congruent. And we can say congruent or equal, it doesn't matter to me. And the formula associated with this is that specifically each angle is, we would take n minus 2 times 180, and then it's back to that same question where I was asking, if it's a 3-gon, how many angles? 3. If it's a 7-gon, how many angles? If it's an n-gon, I would take this and I would divide it into n equal pieces. This is the key to that last problem. Everything else that I would put on your note card, in all honesty, would just be the theorems that you can't remember. I would do something very similar like this for rectangles and rhombus and trapezoid and kite. The only other random theorem that I would suggest is Pythagorean theorem if you don't know how to use it. Cool. All right. I will try to have those graded for you by 3:30, but I'll post a video right now before 6th hour so that if I don't get it graded for you, you can still look over the practice test.
All my notes